The roar of the engine, the rush of adrenaline, the blurring scenery as you accelerate to unimaginable speeds. These are the sensations that car enthusiasts live for, and at the heart of many of these high-performance machines lies a marvel of engineering, the turbo engine. To understand the significance of turbo engines, we must first grasp the fundamentals of how a traditional internal combustion engine operates. These engines have been the backbone of automotive technology for over a century, providing the power needed to move vehicles of all shapes and sizes. In a conventional engine, air is drawn into the cylinders through a process known as natural aspiration. This means that the engine relies on atmospheric pressure to push air into the combustion chamber. The efficiency of this process is crucial for the engine's performance. This air, combined with fuel, ignites to create the explosions that drive the pistons and ultimately power the vehicle. The precise mixture of air and fuel is essential for optimal combustion, which in turn affects the engine's power output and fuel efficiency. However, the amount of power an engine can produce is limited by the volume of air it can ingest naturally. This limitation is a significant factor in the performance of naturally aspirated engines. Engineers have long sought ways to overcome this constraint, leading to the development of various technologies aimed at increasing air intake and improving engine efficiency. One such revolutionary technology is the turbocharger, which forces more air into the engine, thereby increasing its power output without significantly increasing its size or weight. Before we delve into the intricacies of how a turbocharger works, let's take a closer look at its essential components. At its heart, a turbocharger is a relatively simple device consisting of two main parts, a turbine and a compressor. These two components are connected by a shaft, and the entire assembly is housed within a compact unit, typically mounted to the engine's exhaust manifold. Now let's examine how these components work in harmony to boost engine performance. As the engine burns fuel and air during the combustion cycle, it expels hot exhaust gases. In a naturally aspirated engine, these gases would simply exit through the exhaust system. However, in a turbocharged engine, the exhaust gases are routed through the turbocharger's turbine housing. Section 3. The boost threshold. As the compressor spins, it draws in ambient air and compresses it, increasing its density and pressure. This compressed air is then forced into the engine's intake manifold, where it mixes with fuel. The increased air density means that more oxygen is available for combustion, allowing the engine to burn more fuel and produce significantly more power. Section 1. Power play turbo versus naturally aspirated. The most striking difference between a turbocharged engine and a naturally aspirated engine lies in their power delivery characteristics. In a naturally aspirated engine, power builds linearly with engine speed. As the engine spins faster, it draws in more air, allowing it to burn more fuel and produce more power. However, this power increase is gradual and reaches its peak at a relatively high RPM. Section 2. Efficiency and the balance. Beyond their power delivery differences, turbocharged engines also offer potential advantages in fuel efficiency. By forcing more air into the cylinders, turbochargers allow engines to extract more energy from the same amount of fuel. This means that, in theory, a smaller, turbocharged engine can achieve similar power output to a larger, naturally aspirated engine while consuming less fuel. While turbocharged engines offer compelling advantages in terms of power and efficiency, they also come with certain drawbacks. One notable disadvantage is increased complexity. The addition of a turbocharger introduces more moving parts and components, which can increase the potential for mechanical issues and maintenance costs. The concept of turbocharging, while synonymous with high-performance cars today, didn't originate in the automotive world. Its roots can be traced back to the early 20th century, where it first found application in the realm of aviation. In the early days of flight, engineers faced a significant challenge: maintaining engine power at high altitudes. As aircraft ascended into thinner air, their engines, starved of oxygen, would struggle to produce sufficient power. While turbocharging initially took flight in the skies, it wasn't long before automotive engineers recognized its potential for boosting the performance of ground-based vehicles. The first attempts to incorporate turbochargers into cars emerged in the 1960s. One of the earliest examples was the 1962 Oldsmobile Jetfire, a stylish coupe that broke new ground by offering a turbocharged V8 engine as an option. Section 3. Turbocharging finds its stride, the 1970s and 80s. Despite the initial hurdles, automotive engineers persisted in refining turbocharger technology. The 1970s witnessed the rise of turbocharging in motorsports, particularly in Formula One racing. The use of turbocharged engines in Formula One pushed the boundaries of performance, leading to significant advancements in turbocharger design and reliability. Section 4. Turbocharging embraced from niche to mainstream. Throughout the 1980s, turbocharging gained widespread acceptance in the automotive industry. Car manufacturers increasingly embraced turbocharged engines as a means of achieving both high performance and improved fuel efficiency. The development of smaller, more efficient turbochargers helped to mitigate issues like turbo lag, making turbocharged engines more responsive and enjoyable to drive. Section 1. The turbocharged revolution, efficiency and performance converge. In the world of automotive engineering, a significant transformation has been quietly unfolding, reshaping the landscape of car performance and efficiency. The dawn of the 21st century marked a turning point for the automotive industry. As the new millennium began, car manufacturers faced unprecedented challenges and opportunities. The early 2000s saw a surge in technological advancements and a growing awareness of environmental issues. Faced with increasing environmental concerns and stricter fuel economy regulations, car manufacturers sought innovative ways to reduce emissions and improve fuel efficiency without compromising performance. The pressure to meet these new standards led to a wave of innovation and creativity within the industry. Turbocharging, once relegated primarily to high-performance vehicles, emerged as a key technology in this new era of automotive engineering. This technology, which forces more air into the engine to increase power, became a game-changer. It allowed for smaller engines to produce the same, if not more power than their larger, naturally aspirated counterparts. The development of smaller, more efficient turbochargers, coupled with advancements in engine management systems, allowed manufacturers to extract impressive power outputs from smaller displacement engines. These advancements not only improved performance, but also significantly enhanced fuel efficiency. Engineers worked tirelessly to refine turbocharger technology, making it more reliable and accessible for a wider range of vehicles. The result was a new generation of cars that offered the best of both worlds, exhilarating performance and remarkable efficiency. This convergence of efficiency and performance has set the stage for the future of automotive innovation, promising even greater advancements in the years to come. Downsizing with power, the rise of small displacement turbo engines, the shift towards smaller turbocharged engines gained momentum rapidly. Car manufacturers across the globe began introducing models equipped with a new breed of power plants that defied conventional expectations. Compact cars, once known for their modest power outputs, were now capable of delivering surprising acceleration and performance thanks to their turbocharged engines. Section 3. Turbocharging in the age of electrification. A powerful partnership. As the automotive industry continues its transition toward electrification, turbocharging remains a relevant and valuable technology, while electric vehicles and hybrid electric vehicles are rapidly gaining popularity. Internal combustion engines, particularly those equipped with turbochargers, are expected to play a significant role in the automotive landscape for the foreseeable future. Section 1. The evolution continues. Innovations in turbocharging technology. The story of turbocharging is far from over. As with any transformative technology, innovation continues to push the boundaries of what's possible. Engineers are constantly striving to improve the efficiency, performance, and responsiveness of turbocharged engines, exploring new materials, designs, and control strategies to extract even greater benefits from forced induction. Section 2. The future of forced induction turbocharging in a changing world. The automotive landscape is undergoing a period of unprecedented change driven by advances in electrification, automation, and connectivity. In this evolving landscape, turbocharging is poised to remain a relevant and adaptable technology. While electric vehicles are undoubtedly gaining traction, internal combustion engines, particularly those enhanced with turbochargers, are expected to play a significant role in the automotive industry for many years to come. Section 1. A legacy of power and innovation. The turbocharger, once a niche technology confined to the realms of aviation and motorsports, has left an indelible mark on the automotive industry. Initially, it was a groundbreaking innovation that allowed aircraft to fly higher and faster, overcoming the limitations of thin air at high altitudes. This technology soon found its way into the world of motorsports, where speed and power were paramount. Classic race cars, equipped with these early turbochargers, began to dominate the tracks, showcasing the immense potential of this technology. From its humble beginnings as a means of overcoming the challenges of high-altitude flight, to its widespread adoption in everyday cars, the turbocharger has consistently pushed the boundaries of engine performance and efficiency. In the early days, turbochargers were primarily used to enhance the performance of high-altitude aircraft, allowing them to maintain power at altitudes where the air was thin. This was a revolutionary development, as it enabled aircraft to fly faster and higher than ever before. As the technology evolved, it was adapted for use in automobiles, where it quickly became a game changer. Early turbocharged cars were known for their incredible speed and power, but they were also notorious for their lack of reliability and efficiency. What began as a quest for greater power has evolved into a pursuit of a delicate balance between performance, fuel efficiency, and environmental responsibility. Modern turbochargers are marvels of engineering, designed to extract the maximum amount of power from an engine while minimizing fuel consumption and emissions. This has been made possible through advances in materials, science, computer-aided design, and precision manufacturing techniques. Today's turbocharged engines are not only more powerful and efficient than their predecessors, but they are also more reliable and environmentally friendly. Engineers have worked tirelessly to refine the technology, addressing issues such as turbo lag and heat management to create engines that deliver smooth, responsive performance. The turbocharger, once synonymous with raw speed and exhilarating acceleration, has become an integral tool in the automotive engineer's arsenal, enabling the development of vehicles that are both thrilling to drive and kinder to the planet. In the world of high-performance sports cars, turbochargers provide the power and acceleration that driving enthusiasts crave, while in the realm of everyday vehicles, they help to improve fuel efficiency and reduce emissions. This dual role has made the turbocharger an indispensable component in the quest for sustainable mobility. As we look to the future, the turbocharger will continue to play a crucial role in the development of new innovative powertrains that meet the demands of a changing world. Whether it's through the integration of hybrid and electric technologies or the development of new materials and designs, the legacy of power and innovation that began with the turbocharger will continue to shape the automotive industry for years to come.